All right, here we are again. Chapter 8, Section 5, Add and subtract rational exponents, or rational expressions. So first thing, you need to know what a complex fraction is. It's a fraction that contains a fraction in its numerator and denominator. So it's a fraction in numerator and denominator. So a real simple one would just be if you had 2/3 divided by 3/4. That is a complex fraction. We will most likely be seeing things like x plus 2/3 all over 2x minus 4 divided by 2, something like that. You have to remember that when you divide by a fraction, it's the same as multiplying by its reciprocal. Please remember that. Divide by fraction equals multiply by reciprocal. So the reciprocal of 3/4, this would be 2/3 times the reciprocal 4/3. To add or subtract rational expressions with like denominators, simply add or subtract their numerators. Please, this is some stuff from a long time ago, back from probably elementary school, where when you're adding 1/2 and 3/2, the question is how many halves are there? There are 4 total halves here. The denominator stays the same, you simply add or subtract the numerators. Then you replace the result over the common denominator. So let A, B, and C be polynomials. So basically what we have here is you have the numerators being added, dividing by the common denominator. The A numerator being subtracted, divided by the common denominator. So adding with like denominators, remember you're following these rules. If they have 6x, if the denominators are the same, you add the numerators, 9 plus 2, so you end up with 11/6x. Let's take a look at number 1 of the guided practice. It says 7/12x minus 5/12x. The common denominators, denominators are the same, so it becomes 7 minus 5/12x, which becomes 2/12x. And now you have to remember what we did last class with simplifying radical, or simplifying the fraction. 2/12 reduces to 1/6x. Number 2, 2/3x squared plus 1/3x squared. The denominators are the same. Since they are the same, you add the numerators. 2 plus 1/3x squared. That equals 3/3x squared. And now these here reduce. They cancel out. They become 1. So my final answer is 1/x squared. That should be pretty straightforward for you. Where it gets a little bit confusing now is when you have to add or subtract with unlike denominators. To add or subtract two rational expressions with unlike denominators, find the least common denominator. All right, the least part is important only because it means you won't have to reduce later. You just have to have a common denominator. Okay, so I'm going to come down here, I'm going to say, or any common denominator. It doesn't have to be the least, but it'll make it easier. So when you have the least common denominator, which is the least common multiple of the denominator. So basically what you're looking at here is you could rewrite each rational expression using the least common denominator, then add or subtract using procedures for like denominators. So here, a plus b, a over c plus b over d. What happens is you have to find a common denominator. For c and d, the common denominator is um, CD. So you would multiply this by d over d and this by c over c. And now since CD is in the denominator, you rewrite this as AD plus BC all over CD. Now subtraction, it's the same. You find the least common denominator. It ends up being AD minus BC all over CD. Now we'll do one of the examples from the book. All right. So sometimes it's pretty tricky to find the least common denominator. So what you're going to look for here is, again, what can you multiply by to make this look just like this over here? First of all, let's clean this stuff up a little bit. 4x squared just is 4x squared. And then over here, though, you could rewrite this as a 2x times x plus 2. Now, finding the least common denominator is going to be pretty tough. So what you might want to do is you could get into the habit of just saying to yourself, I'm going to multiply, I need to multiply by this over here, by this denominator on this side. What I mean by that is we're going to multiply by 1. You're going to multiply by 4x squared over 4x squared. That's multiplying by 1. Here, you're going to multiply by 2x times x plus 2, and then in the denominator, 2x times x plus 2. So now the denominators are all 2x times x plus 2 times 4x squared. We did this part right here and this part right here to make the denominators the same. Now we have to just rewrite everything that's here with addition. So here we have a 2x times an x plus 2 times a 5 plus a 4x squared times an x plus 1. All right. The least common denominator is sitting right here. We can't do any canceling because of this addition. All right. So again, we've multiplied the right fraction by the denominator over the denominator, this fraction by the denominator over the denominator. Now we have to continue to do some cleaning up. So we distribute 5 times 2 is 10. So I'm going to run out of room, so I'm going to just say that 5 times 2 is 10. So now I'm going to say that I've got a 10x here. And this is gone. 10x times the x. All right, let's look at that. 10x times x. 10x times x is 10x squared. 10x times 2 is plus 20x. And then we have a plus, let's distribute. That's plus a 4x cubed. And then a plus 4x squared. All right. Now, it's 2x times x plus 2 times 4x squared. So what we have to now take a look at is we have to take a look at the fact that this up top needs to be fixed. Change it around a little bit. And notice that everything's divisible by 2 and everything's divisible by x. So if we take a 2x out, what we have left over is a 10x plus, oh, I'm sorry, not 10x. We factored out a 2, so this would be 5x. Factored a 2x out of here, you'd end up with plus 10 plus 2x squared plus 2x. All right. I should have done something earlier. I should have put this and this together because they are like terms, but we can do it now. So we have a 2x here times 2x squared plus 7x plus 10. You're all dividing by 2x times x plus 2, 4x squared. And now you should see from our last lesson that these cancel out right here, and our final answer ends up just being this right here. This is our simplified form, adding them. All right, let's take a look at the next one here. Remember, we looked at the denominators. 3x minus 9, you can factor out an x. Or I might factor out a 3. Here, minus x plus 4 over. This right here shows the difference of perfect squares. So it becomes x minus 3, x plus 3. And you could, if you wanted, okay, now that we factored it, you could, if you wanted, find the least common multiple, or you could just say multiply over here by 3 times x minus 3 and over here by x minus 3 times x plus 3. But notice, they already have two pieces in common. So we have to just multiply by 3 over 3 and by x plus 3 over x plus 3 to get the common denominator of 3 x minus 3 x plus 3. Up top here, it becomes 7 times x plus 3 minus 3 times x plus 4. And distribute and combine like terms. So that's 7x plus 21 minus 3x minus 12. Let's combine the next step here. Let's combine 7x minus 3x becomes 4x. Combine the 21 and the minus 12 becomes 4x minus 9. And when I rewrite this part here, you should be able to see that at no point can I simplify anything out. This right here ends up being your answer. All right, so here's some checkpoints. Check it out. Same base, or I'm sorry, same denominator, you simply combine the numerators. Okay, pause the video and try this on your own. Same base, so what should you do? All right, once you've finished, it should be that you have 13 plus 2 over 3x. 13 plus 2 is 15 over 3x. And that reduces by a factor of 3 to 5 over x. All right, here's a checkpoint where we have to get a common denominator. Notice, difference of perfect squares. That's x minus 3 times x plus 3. Over here, man, we probably should try to factor that. See what can help out. And factors of 9 that add up to 6. Well, that's x plus 3 times x plus 3. All right, now that you can see what the denominators are, you look to see what do they not have in common. Here's an x plus 3, and here's an x plus 3. Well, we need two of them. So here we have to multiply by another x plus 3. Here, there's no x minus 3, so we multiply by x minus 3. And now we have the common denominator of x minus 3 times x plus 3 times x plus 3. Up in the top, you'd have x minus 3 times x plus 1 plus 6 times x plus 3. And now we have to do some work. Now we have to FOIL this. That becomes x squared. When you work it all out, it becomes x squared minus 2x minus 3 plus 6x plus 3. And before we rewrite the denominator, let's combine like terms. Let's combine like terms. So the x squared, there are no other x squareds. Since there are no other x squareds, we just have an x squared. Here's a minus 2x and a plus 6x. That means plus 4x. Here's a minus 3 plus 3. That becomes 0. So now I have the equation. All right. Hold on a second. I think I made a little mistake here, so I hope you're not writing in pen. When I distributed this 6 onto the x, I didn't distribute it onto the 3. That means this isn't a plus 3, it means it's a plus 18. So this red is the correction that we're making, which means down here I would have a plus 15. All right. And now, if you go about trying to factor all of this, factor this here, factors of 15 that add up to 4, 3 and 5, 1, we can't. We cannot factor this. Therefore, this is your final answer. All right, I'll try not to make a mistake on this one. Notice, though, here we can take out a 4x, I think. Yep. So now we've got an 8 over 4x squared minus 2 plus x all over 4x times 2x minus 3. So look to see what they have in common. They have a 4 already in common. They have 1x already in common. So that means to multiply this, all that we're missing from this to this is an x squared. So you multiply by x over x. Here, we've got the x squared. We're just missing the 2x minus 3. So our denominator will be 4x squared times 2x minus 3. Our numerator will be 8 times 2x minus 3 minus x times 2 plus x. So we now simplify that. That's the new part, finding the common denominator. Now you have to do the old part of looking at the numerator and distributing 8 into 16x minus 24. And then we're subtracting 2x and subtracting x squared. So clean this up some more. A 6x minus 2x, that's a 14x. You have a negative x squared plus 14x minus 24, all divided by 4x squared, 2x minus 3. And there are no factors of negative 24 that add up to positive 14. All right, we're going to go ahead and skip guided practice number 5, but we'll look at number 6. I'm sorry, and 6. We'll skip those two. They're just finding the least common denominator. So number 7, 3 over 4x. Everyone, this is from page 584. 3 over 4x minus 1/7. So we need a common denominator between 4x and 7. And since they don't have anything in common right now, we're just going to go ahead and multiply the right fraction by the left side's denominator and the left side by the denominator of the right side. So now what you can see, 7 times 4x, 7 times 4x, you end up with a 28x in the denominator. 7 times 3 is 21, minus 1 times 4, minus 4x. And nothing can be simplified from here. This is your final answer. Guided practice number 9, we'll take a look at that. It's x over x squared minus x minus 12, and you're adding 5 over 12x minus 48. All right, so let's do some factoring here. The denominator on the left, factors of 12, of negative 12 that add up to negative 1. Well, 3, 4 will probably work. So it's x, so minus 4, and it's a plus 3. Now again, the reason we do this part is because you can see there's a factor of 12. 12 divided by 12, 48 divided by 12, ends up being x minus 4. So by doing this factoring, it makes our job easier when finding the least common multiple, or the least common denominator, because they already have an x minus 4 in common. So all you have to do is x plus 3 over x plus 3. And over here, all you have to do is by 12 over 12. So now our denominator is 12 times x plus 3 times x minus 4. Our numerator is 12x plus 5x plus 3. From here, distribute 5 into there. You end up with, let's see here, 12 plus 5x plus 15 divided by 12, x plus 3, x minus 4. And so for your final answer, so I did this over here because I didn't have room. Your final answer, 12, 15, together gives us 27. So you end up with 5x plus 27 divided by 12 times x plus 3 times x minus 4. A lot of this is just remembering what to bring down and what not to bring down. All right, complex fraction is a fraction that contains a fraction in its numerator or denominator. All right, method 1, simplify the numerator and denominator by writing each as a single fraction. Then divide the numerator by the denominator. Okay. So what this is talking about, this is saying writing each as a single fraction. And the other method is finding the least common denominator. I'm going to say that you should probably use method 1, because all method 1 does is method 1 basically looks at this as a separate problem. If we were to look at x plus 1 divided by 15 plus 4 divided by 15, and we put those together, 15, same denominator, therefore the result will have a denominator of 15, and the numerator, x plus 1 plus 4, is x plus 5. So what that does for us is now we have 8 over 5x divided by x plus 5 divided by 15. So now you're dividing by a fraction. And you can remember at the beginning, when you divide by a fraction, you multiply by its reciprocal. So now all we have is 8 over 5x. Multiplying by its reciprocal is 15 over x plus 3. And now it's just like the problems we did from 8.4. 15 and 5, they reduce. And our final answer is 24 over x times x plus 3. That's how you can set up this one right here. Oh, I'm sorry, that's not a 3, is it? It's a 5. It's a 5. That's a 5. That's a 5. But either way, the process is correct. So, try the same thing here. Try the same thing. Go ahead and look at the denominator as a fraction, as a problem all on its own. So, we need to combine these fractions somehow by finding a least common denominator. 3x, they don't have anything in common, so you have to just multiply by the other side. So, what we've got going here is the denominator is now 3x times x plus 1. The numerator is 1 times x plus 1 plus 6x. All right, one final change here puts us at 7x plus 1 all over 3x times x plus 1. So, we now have converted this fraction denominator into that. So we have a whole new problem here. Oops. And you're going to be upset, I'm sure, because now it's like doing 4 problems in one. Basically what happens here, everyone, is you're dividing by a fraction. So for the 5th or 6th time, when you divide by a fraction, it's the same as multiplying by its reciprocal. Sorry, this is an x right here, 3x. So it ends up being 3x times x plus 1 divided by 7x plus 1. Now, you should be happy because here's an x plus 1 in the numerator, and x plus 1 in the denominator. 2x times 3x gives us 6x, and all that's left in the denominator is 7x plus 1. That is how you go about solving these. All right, it looks like I don't think we have very much more to go. Just a few of the checkpoints. I think we can do this denominator quite quickly. Here's a 2 and a 2. So we add the denominators, 8 plus 3x over 2. And the denominators are the same here, so that's a 4. And we got 6x minus x. So, dividing by a fraction is the same as multiplying by its reciprocal, plus 3x. So now I have 6x minus x all by 2 divided by 4 times 8 plus 3x. And the only thing we can reduce here well, let's start by reducing some of this. This becomes, that reduces to 1. All right, I had to pause the video because I was looking at this and missing something. Everyone, what you're looking at here is a fact that, look right here, 6x minus x. How many x's is that? Yeah, it's a 7x. So these two, the 6x, that combines together to a 5x. I mean, the denominators that reduces to 1, this reduces to 2, and when I distribute, becomes 6x plus 16. All right, this is your final. All right, one more. This time the denominators are not the same, so we're going to need a little bit more work here. So we're going to have to look at this as a many step problem. All right, this has an x squared, but it's missing multiplying by 2. This has a 2 and an x. It's missing the x squared, though. So now you have 5x plus 7, 5 times x, and then 7 times 2, which is 14, all over 2x squared. The other denominator is very similar. Here, this is missing the x squared, so you got to multiply by x. This is missing the 2, you got to multiply by 2. And now you end up with 6 minus x all over 2x squared. So now I have the equation 5x plus 14, 2x squared, all over 6 minus x over 2x squared. All right, and since we did these separately as two separate problems, and now we put them back together again, we multiply by the reciprocal. And you should see right away that something nice happens. You should see that the 2x squared cancels, and all you're left with is 5x plus 14 all over 6 minus x. All right, we're going to forego the guided practice so that this doesn't take too long. Watch those other problems again if you have questions. I would take a look at these and do maybe some of the easier ones, and then we'll work on the rest of them during class. Good luck.